Hello everyone, welcome back. In this lesson we shall look at types of events, and we are going to start by looking at undefined events. So for undefined events there is no restriction on the intersection. We don't have any restriction on the intersection. So we shall see what this means as we look at numerical examples. So our first example reads, events A and B are such that probability of A is equal to 19 out of 30, probability of B is equal to 2 out of 5, and probability of A union B is equal to 4 out of 5. And Roman 1 that has to find probability of A complement intersection B complement. Yes, so we saw it from De Morgan's rule. We saw that probability of A complement intersection B complement, we can have that complement factored out and intersection changing to union. So that probability is actually the same as probability of A union B, but complement. And we saw that from complement of events, probability of A union B but complement is the same as 1 minus probability of A union B, which is actually the same as 1 minus probability of A union B, which is 4 out of 5. And therefore we shall end up with 3 out of 5 as our probability of A complement intersection B complement. Then part B wanted us to find probability of A intersection B. So what shall I use in that case? Because in the question I'm only given probability of A union B and probabilities of A and B. So I know that my probability of A union B, okay, this was our first question and we have answered it. I know that my probability of A union B is actually equal to probability of A plus probability of B minus probability of A intersection B. So by substituting, I'll be able to get my probability of A intersection B. So probability of A union B was given as 4 out of 5. Probability of A was given as 19 out of 30. Probability of B was given as 2 out of 5. And I want my probability of A intersection B. So if I collect like terms and solve everything, I'll end up with my probability of A intersection B as 7 out of 30. I hope that's clear. Then they also wanted us to find probability of okay, this was a repetition, probability of A complement union B. That is us to find probability of A complement union B. So how shall we get that probability of A complement union B? Now I didn't tell you something, but remember we said that if I have probability of A union B, it is actually equal to probability of A plus probability of B minus probability of A intersection B. Now what happens if I'm looking for probability of A complement union B? So if I'm looking for probability of A complement union B, I shouldn't be stressed at all. I just quote the same formula, just that wherever I have A, I'll keep on adding a complement to that A. So it means that I'll have probability of A but complement plus probability of B minus probability of A. Where I have A, I'll put a complement intersection B. Then I will be able to get my probabilities. I know that probability of A complement is the same as 1 minus probability of A. So I'll have 1 minus probability of A, which was given as 19 out of 30, plus probability of B, which was given as 2 out of 5, minus probability of A complement intersection B, which is actually the same as probability of B only. Okay, let me first write it. Probability of B only, which is the same as probability of B minus probability of A intersection B. So I can substitute. So I'll have 1 minus 19 out of 30 plus 2 out of 5 minus probability of B. So in the question it was given as 2 out of 5 minus probability of A intersection B, which we calculated and got as 7 out of 30. So I will simplify all that and I'll end up with 3 out of 5 as my answer. So probability of A complement union B is actually equal to 3 out of 5. Then part A wanted us to find probability of A intersection B but complement. So probability of A intersection B but complement, which is actually the same as probability of A only, and we saw that such probability is actually equal to probability of A minus the intersection. Yes, but my probability of A was given in the question as 19 out of 30 and my intersection was calculated as 7 out of 30. So I'll end up with 12 out of 30, which will reduce to 2 out of 5. So my probability of A intersection B but complement is actually equal to 2 out of 5. Next, we are going to look at example 2, which reads, events C and D are such that probability of C is equal to 0.3, probability of D is equal to 0.4, and probability of C intersection D is equal to 0.1. And Roman A wants us to find probability of D complement. Yes. So I know that probability of D complement is actually equal to 1 minus probability of D. So we shall have 1 minus probability of D, which was given as 0.4, and therefore I'll end up with my probability of D complement as 0.6. Then Roman 2 wanted us to find probability of C intersection D complement, which is the same as probability of C only. So probability of C intersection D complement is actually equal to probability of C minus probability of C intersection D. I'm just looking for C only, so I'll get the entire set C and remove the part that contains a bit of D. But my probability of C is equal to 0.3 and my probability of C intersection D is equal to 0.1. So when I calculate, I'll be able to end up with probability of C intersection D complement as 0.2. Then Roman part C wanted us to find probability of C complement intersection D complement. So there I can use De Morgan's laws. Probability of C complement intersection D complement. But we say that the complement factors out and intersection changes to union. So I'll have probability of C union D but complement. I hope that's clear. Yes, which is the same as 1 minus probability of C union D. But are we given C union D in the question? No. But it's true that we can calculate for it. So we know that probability of C union D is the same as 1 minus probability of C plus probability of D minus probability of C intersection D. Okay. So if I am to make substitutions, okay, I can carry to the next page. We'll have said probability of C complement intersection D complement is equal to 1 minus probability of C plus probability of D minus probability of C intersection D. So by substituting what I was given in the question, I'll have 1 minus 0.3 plus 0.4 minus 0.1. And when I simplify that, I'll be able to end up with my probability as 0.4. So that is the probability of C complement intersection D complement. Then part D wanted us to find probability of C complement union D complement. Okay. So probability of C complement union D complement. We shall still apply De Morgan's rules. We shall factor out the complement and union shall change to intersection. So we shall have probability of C intersection D but complement. which will be the same as 1 minus probability of C intersection D. But from previous examples, we calculated probability of C intersection D and got it as 0.1. So we shall have 1 minus 0.1, which will give us 0.9 as our probability of C complement union D complement. Thank you very much for listening. Let us meet in the next lesson for further examples. Thank you very much.